Fruitport High School chemistry students. I'm having some technical issues on my third try trying to record this video. I hope it works. So hopefully you've watched how to separate mixtures, learn some vocabulary up to distillation, where you saw this slide here, where we went over the definition, where we can separate things based on solubility or boiling point. And so this is a picture of like a cartoonist version. They make these things like moonshiners and distilleries, right? But I want to show you this image here. And so how this works is you put a sample down in this little corner where I'm pointing with the mouse, and maybe it's salt water. And if we heat it up, only the water will actually boil, and the salt will recrystallize. But the water won't escape because it will travel up this tube and then travel down this tube. And you'll see here there's an outer tube of cold water to make sure the steam condenses. And gravity and that diagonal tube cause the water to drip, 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 or whatever the sample is out, okay? You could also put two liquids with different boiling points here. If one liquid we know boils at 80 degrees and another at 90 degrees, well, if we heat this up only to 80 or 81 degrees, only the molecules of the lower boiling point sample will actually evaporate or vaporize or boil into a vapor, and then it will eventually condense before drip, 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 leaving behind the other sample, because that stuff won't intermix. It won't boil because the temperature was never warm enough, right? So there's some distillation for you. Another fun one is a centrifuge. A centrifuge works by spinning something really fast. If you've been on a carnival ride that spins really fast, that's like a giant size centrifuge. And in the chemistry lab, we'll get to work with one. In a hospital lab, they might take like a vial of blood, spin it really fast to separate all the different components of blood into layers. And those will separate based on their different densities. You also might see, well, here's a picture of a centrifuge in a lab. This would spin really, really fast here. Okay, this is another centrifuge that humans can fit in. It's like this giant arm to train astronauts and fighter pilots not to pass out while they're flying a plane. Otherwise, there's so much gravity, formed with the centrifugal force that there not enough blood might get to the brain, and so they get trained on how to avoid passing out. All right, and our last slide is crystallization. Crystallization is just letting things crystallize. Gems and things in caves form by this, but you would see it more likely if you had something dissolved in water, and if you actually just let it, the water part evaporate, the part that was dissolved wouldn't leave with the evaporation, and it would crystallize. You use that when you make rock candy. Sugar water slowly turns into rock candy if the water slowly evaporates. All right. Again, this is not as good as distillation because the water escapes and we don't have it anymore. But if it was important to catch the water, we should use distillation. If it's not important, then we could just use crystallation. We're good to go. All right, you got some homework now? Look for the directions in Google Classroom.